Hello, my fellow mathletes. Root Beer here with question 22 on the 2005 grade 7 Gauss paper. Okay, if you're looking for the other Gauss paper, the other 2005 Gauss, that'd be the grade 8 Gauss. That'd be a different set of videos, and I'm sure you can click one of the links on the side and it'll take you there. But here we are, question 22 on the 2005 grade 7 Gauss. So let's take a look. Hopefully you've downloaded a copy of this contest and been trying this for yourself. It's the best way to learn. In a bin at the Gauss grocery, the ratio of the number of apples to the number of oranges is 1 to 4. And the ratio of the number of oranges to the number of lemons is 5 to 2. Whoa, okay. So they're throwing ratios at us. That's a little manageable. What is the ratio of the number of apples to the number of lemons? Interesting. Interesting. Okay. So, it's not particularly easy to just go around manipulating ratios. It's a lot easier to say I have this many apples, this many lemons, then I can find the ratio between them. So let's try and set it up like that. Now the information they gave us, 1 to 4 for apples to oranges, gives us some information. So we'll move away from what we did with question 21. Now we're on question 22. So, since the number of apples to the number of oranges is 1 to 4, the definition of being able to be put in this sort of ratio, so since this is 1 to 4, that means we can find a number k so that the number of apples is 1 times k and the number of oranges is 4 times k. This is what it means to be able to put these numbers in the ratio 1 to 4. If it were something like 2 to 3, we'd have a 2 here, 2k for the number of apples, and 3k for the number of oranges. It doesn't actually matter right now what that number k is. The point is such a k exists to get both of these equations going. That's what it means to be in a ratio like that. But I'm betting you probably knew that now. They gave us another ratio. Number of oranges to the number of lemons. So we also know number of oranges to the number of lemons is 5 to 2. So we can find another number. It's got to be a different number than k until we can prove that it's equal to k or something like that. So we'll pick another one. Let's use the fancy L. So we can find L. We use fancy L in math rather than regular L because regular L looks a lot like 1. So the number of oranges is 5L, and the number of lemons is 2L. Okay. So, what can we do with this information? Well, I have an expression for the number of oranges. So I know 5L is the number of oranges, but that's also the same as 4k. So I can find a relationship between L and k. Is L equal to k? No, not really. But we do find some relationship. For example, this tells us if we divide both sides by 4, 5/4 of an L is 1k. Okay. Well, the number of apples is exactly 1k. And what do we want? We want apples to lemons, right? Not lemons to apples. So, we want this ratio, apples to lemons. But the number of apples is k. The number of lemons is 2L. But of course, k is 5/4 of an L. Okay. So one thing we can do with ratios stay the same whether or not we multiply both sides by the same number or divide both sides by the same number. So what I'm going to do is I'm going to divide both sides by L. Now this isn't quite a nice looking ratio. Usually ratios are whole numbers to whole numbers. So we're going to multiply both sides by 4. We'll get 5, and we'll get 8. Okay? Now, hopefully this matches with one of the answers they've given. If it doesn't, that's okay. We can use you're allowed to divide by the same number on both sides and multiply by the same number on both sides to try and make it fit with one of the possible answers. But I think I saw 5 8. So the 5 to 8. So let's check here. Yeah, it's right in the middle. C, 5 to 8. Fantastic. We're going to flip the page in anticipation of our next question, and that will be question number 23. So thank you for joining me for this 2005 Gauss paper, grade 7 Gauss. We're almost at the end. We got 3 questions to go. I hope to see you guys for more of the videos in the future. So long.